Welcome back to another video in the series. And the next topic in this SC900 series is defense in depth. Yes, we have covered this topic in previous videos. So, for the people who are a regular visitor of this channel, already aware of it, defense in depth, but the people who are trying to learn or new, it would be really nice that they will learn the new concept, defense in depth. Concept is old, but for them it will be new. It is also called DID, not Dance India Dance, but of course, defense in depth, right? So, as the name says, what we are doing, we are applying defenses as we are going in. What does that mean? Let's take a simple example. Let's take the simple example of the society and apartments again. This will help us understand. All right. So what we have a society, right? Inside society, we have multiple apartments, right? Let's suppose we have two apartments here. Oh, sorry, two towers, and inside towers we have multiple apartments here, right? Like this. We have multiple apartments. All right. Now, if we think defense in depth from this perspective, because everybody is getting inside the society from a gate, they may have two gates or one gate, it depends the kind of society we have. So who we have at the beginning when anybody enters the society, they are guards. We have stickers on the vehicles, right? And if you are not somebody who resides in the society, they will ask you to write down your information, they will let you in. Then we also have security here on the tower. They will ask you again which tower, where it is going. They might have CCTV cameras, even here, and maybe in the elevator as well. Anyways, then you reach your apartment. Now, the first security is here, second security is in the tower, and in the apartments, nobody keep it open. They put their locks, right? There is another security. And inside the apartments, you have multiple rooms. You might apply locks there as well. And if you have some kind of important things, or maybe money, gold, documents, you keep that in a locker inside the room, which is again locked. And locker has its own lock. So you see, there are multiple layers of security to secure your data. Here the data is your valuables. So in any application, what is the valuable that people are after? Well, that is data. Everything is about data. Everything is revolving around data, right? So the first layer is data. If you are getting from inside, then it is data. If you are coming from outside, then it is your physical. Okay, why? Because data is residing where? Data is residing in a physical data center. This data center could be belong to you if it is on premises, and if it is cloud, it may be belong to Microsoft because it is Azure. So it is physical, or physical layer, you could say, or you could say data layer here. Why we are calling layer? Because defense in depth. We are applying defenses on all the layers. We are defining it like that. All right, now Swachh Bharat ka irada kar liya humne is going outside early in the morning. All right, all the layers. Now the concept, I hope you got the concept. All the layers which are involved in serving an application to the consumer needs to be protected, so that if one layer is compromised, the other one will take care. If the people can get inside the society gate by hiding their face or giving the fake information, then they will get caught during the tower security. If they survive that, then they'll find lock on the apartment. If they somehow manage to get in the lock, there are other locks in the rooms, there are other lockers in the room. Until then, somebody will definitely get to know something is wrong, and they will pick that thief and put it away. Right. Similarly, we have to apply security on the physical layer up to the data layer. So what all layers are involved in between, we need to understand that. So physical layer, let's start one by one so that you would have a pretty good idea. So if we have to explain or define defense in depth, it is a security approach. Okay, what it is a security approach where multiple layers of security controls are placed throughout an IT system to protect against threats. So we can say multiple layers involved needs to be secured accordingly. Okay, because the way you're securing your physical layer, the means would be different for the data layer. Okay, so that's the idea accordingly. Now, each layer has a mechanism that provides security to different assets and protect them from various factors. So let's see what are those one by one. So you're running an application. You have run the your virtual machine. Inside a virtual machine, what do you have? You have application, okay, and inside the application you have data, right? So this is your VM, or you could say compute. This is your application, right? And application has data. So this compute is we are creating on Azure portal, right? As we explained in the previous video, shared responsibility model, and we are running application in it, and application has data. So as of now, you can see there are three layers, and I showed you we are doing this on Azure portal, but at the back end, they are getting spin up in the data center, which is managed by Azure. That is your physical layer. So three layers are absolutely clear, right? Now, this compute, what we do when you create VM for the compute, we create a virtual network, right? So network layer would be the another layer. This is your network layer. Network layer. Right? And before you get your network, there is a perimeter. Like we used to create the DMZ and all, that is your perimeter. Now things are getting clear. So these are multiple layers we define in order to apply security. So these are layers defined by us to apply the security. That's why it is a security approach. Now let's see what all can we do. So if it is a physical layer, okay, so for anybody, if it is a physical layer, for them, these are the physical equipments, physical wall, physical, buildings. It's nothing, no software, right? So what are those? There would be physical servers, or you could simply say hardware, right? Hardware, they cannot see like application and all, it's just a hardware for them. Data centers and the things which is needed to run, like AC or equipments or network devices like routers, cables, backup, or hardware, right? All hardware with, is your physical layer. And you also have a boundary outside the data center so that only authorized person can get in. You show your badge and only they will then allow you. Okay, so eh, what are we protecting this from? Well, the very first is we are protecting it from unauthorized professionals, or not professionals but personnel, right? Or maybe professional thieves or drifters. So unauthorized folks, so that only people who are allowed to get inside the data center uh, can get in, so that they are aware, like whether to touch these cables or hardware or data center network or coolant or not, because if there is any unauthorized folks, they might pull the some plug or get the disk or steal the equipment, those kind of things, intruders. So by default, you'll this data center will go down, which means you also need to think, just for the joke, if something happened, then it's a disaster. Then yeah, if you do not have a DR in place, then you guys are in trouble. So ultimately, physical layer is something very important, and this responsibility, as we talked about in previous video, is taken care by the Microsoft. They have professionals around there, and they do not allow anyone to get in. So that's how dots are connected. So we are protecting from the unauthorized folks who get in and mess up with the data center. Now, how can we protect these folks? There is authorization, like authentication. For example, they have to show your badge, right? Access control. There may be CCTV, just like in our society example. We may have locked server room, just like our society examples. We have encrypt encryption on the data that comes later, but still, if somebody gets in and sees the data, I cannot read the data, it's encrypted. So these are all different mechanism, different layers that we need to protect. If somebody can compromise this one physical layer and gets in and takes the data or hook up its own laptop, it can read the data if we are not protecting this layer, right? So if somebody gets in and data is encrypted, he cannot do anything, right? So on physical layer, we make sure nobody who is authorized, who are not authorized, gets in. So you check badge, you apply CCTV, you do whatever you can. And you might have seen this is happening even in the gym membership right nowadays, like the biometric scanners at its data center entrance, so that they can authenticate you. Only authorized IT staff can access the server room. If it is not even a thief and he gets in, he might break some equipment, which leads to disaster or some downtime. All right. So afterwards, we have this is the physical boundary, and who is we are what we are authorizing or authenticating. We are authenticating, authorizing is the identity. So we have one more layer here. We could say a layer of identity. Which layer? Identity. Okay. So just to, if it is getting confused, not clear, let me call it physical. On physical, we have identity, right? Once we have the identity, only then we can allow the authorized person to get in the physical boundary. Okay. Now, identity layer comes in a different way. From the physical, there is an identity, but if we are running this application on a virtual machine on the Azure portal, which means we also have something called MS Entra. That is another identity. So physical layer identity is for Microsoft, and this identity is for us to protect. So identity layer, all kind of identities here. So this responsibility is Microsoft. This responsibility is ours. So how can we protect the identities? There are multiple ways that will keep on diving deep. We have done in the past. Just for the sake of this video, because this is all about describe its fundamentals, there are multiple ways, like we can apply MFA, we have to apply RBAC, role based access control, with the help of least privilege, only what you supposed to be, just in time access, conditional access, password passwordless, password policies, different kind of. So all the security that can apply on the identity will fall under this identity layer. So physical layer is protected, identity layer is protected with all those security, right? Now the third one is the perimeter layer. It is perimeter around your network. So what are we protecting here? Let me write it down for you guys. Perimeter. So what are we protecting here? We are protecting the network entry points, right? We are protecting the entry point by which we can get into the network layer. So what all could be like your firewalls, VPN, and the proxy servers. And what are we protecting it from? From the external hackers or DDoS attacks or unauthorized remote access, those kind of things, right? So, how can we protect them? Well, as I said, we are protecting it, the entry point where we apply the firewalls, right? So you can use firewall. There are attacks like DDoS attacks, so you can use DDoS protection, because this is where the exposure is happening. For example, you are running a website, so it is on 443, people can access it. So apply the WAF, web application firewall, or IDs and IPs, all those kind of security that we usually talk about will come into the perimeter security, right? Then it comes the network layer. So what are we protecting in the network layer? Network layer, we are protecting our internal networks, okay? Our virtual network, subnet, all those kind of thing. If something happens on the perimeter, somebody can gets in by any means, then this network layer would have a such kind of architecture that it would have a minimum blast radius, or the horizontal movement of the thread will not happen with the help of segmentation on different security protocols like NSGs and other stuff. So what are you protecting it from? Network, the malware which gets in from the lateral movement attacks or the unauthorized internal access. This goes all the way because when cloud comes into the picture, this is very important. Listen to me. I have talked about many times. When cloud comes into the picture, identity is the new security boundary. Right? So identity comes everywhere, and because it's cloud, people are working from anywhere with any device, so we need to apply a proper security on the identity. So even in network, we should have identity protocols in place. All right. So how can we protect our network? Well, we should have network segmentation, as I was saying, separating sensitive system from general networks, and applying the connectivity as such. Like if there is a database which is sensitive, only application server can talk to the database, no web server, no any other server, right? Uh, we should have zero trust network access, private endpoints, secure DNS, encryption, communication like TLS and SSL, those kind of things. We'll dive deep. This is fundamental. Don't forget, this is all about knowing the concept. We'll explore it deep in upcoming videos. So this is network security. After network, what was it? It was compute. Because we are running virtual machine inside a virtual network. So after virtual network, it's compute. So what are we protecting our compute? Well, we are protecting, first of all, inside the compute comes servers, virtual machines, which workloads which are running in the data center. If you come think from the physical perspective, the physical layer, the data center has the servers on which these computes are running, right? And from our perspective, when we are using Azure, it is the virtual machine or the servers that we have created inside our virtual network. So we need to protect those compute because it's a shared security model, right? So we are protecting it from malware, viruses, unauthorized access, ransomware, all those kind of things. So the idea is only authorized people can access, right? And if something happens, what should be in place? If virus gets in, we should have antivirus. If malware, anti-malware, right? So we should have something called endpoint detection and response solution like MS Defender for endpoints. We should have a proper patching of the system in place, the hardening of the systems in place, like secure boot, virtualization based security like VBS, uh, all those kind of things by which we could harden the operating system of our compute will come here, right? Uh, so there are like two ways. First, only people who are allowed supposed to access this compute. Second, if something happens, what are the things in place which can help us? Like if virus gets in, antivirus, anti-malware, a secure boot. There are two things which will help us. Nothing could happen, and if happens, how to protect, right? So two things are happening. Now comes to the, what are we running on the compute? We are running application, and if it's a external application, we are exposing it on the layer 7 HTTPS. So we are afraid of what? The WASP vulnerabilities, layer 7 related issues, DDoS attacks, and all those kind of things. So here we are protecting our web application, APIs, mobile application, software code. And we are protecting from the attackers exploiting application vulnerabilities, SQL injection, those kind of hackers. They would like to have fun, earn money by hacking. They're, it's a cruel world or it's a nice world. Anyways, things happen. We need to protect ourselves, right? So how can we protect this layer? By default, as we said, we should prepare a well secure application first of all. Like we should have a secure software development lifecycle. We should have all kind of testing in place through the DevOps mechanism or DevSecOps mechanism. We should have pen testing all the time to be aware where are the vulnerabilities. The we should have the proper authentication authorization in place, who is accessing the application. We should have secure coding practices, validation, and all kind of different testings that we have in SDLC, software development life cycle. And of course regular patching, and then we should have something in place on the layer, right? Application layer, like WAF. Right. So ultimately, application has something that everyone is after. All the hackers are after. If they get it, they will just encrypt it and make it run somewhere. So what is that? That is data. That is our data layer. So what are we protecting in the data? It could be your customer data, it could be your intellectual property, it could be your health related data, financial data, personal data. And accordingly, there are so many compliance to keep that data in such a way with such regulations or governance, like the PI data, the PCI data, right? So what are we protecting it from? Unauthorized access, data breaches, accidental exposure. The first is we are protecting it from from the perspective, like nothing could happen to our data. And then if happen, that kind of protection. So two kind of protections: unauthorized access, data breaches, accidental exposure. If happens, then encryption. They could not do anything. Backups. If ransomware happened, we could have the recover it from the backups. So data encryption, DLP policies, right management, backup, DR, all comes for the data security. So I hope this is pretty clear now. So defense in depth ensures that if one security fails, other layers provide protection. Each layer focuses on different threats and uses specific mechanism to secure assets from attacks. And this is not it. We have we always have monitoring or security monitoring rather in place. So if some layer compromise, we will get to know, and our SOC team will be initiated. They start working on it, they stop the attack, they start protecting it, right? So we can get to know on this layer, on this layer, on this layer, any layer. When we get to know, we'll stop it, right? The SOC team, like NSG commandos, will get into on the field and help you guys, right? So to reach data, they have to go through multiple layers, and definitely they will get caught in between if we have proper security in place and monitoring and alerting, of course. Now, this is all about defense in depth, but there is something, some principles that we should be aware on which these are working, which is called, earlier it used to be CIA, not the US CIA. We watch a lot of movies, right? But this is CIA triad, which is confidentiality, integrity, and availability. They have added two more thing in it, which is authentication and non repudiation. So CIA triad itself uh, I think it is good enough to explain all, but they have also added two more: authentication and non-repudiation. We should have a look at it from, because this is also part of our topic. So as I said, CIA confidentiality. Anyways, you got the point. So you have seen a lot of movies just like me, or series. You know, any movie where we have these CIA, FBI, or any such security agency, you have seen this dialogue many times. This is confidential, right? So this is exactly what it is, right? And before I go ahead, what are these? These are the principles. These are the principle on which this defense in depth is directly connected to, and you can easily relate it once we through with this. So confidentiality means ensuring that only authorized user can access sensitive information. Right, as I was explaining, we have seen this in movies, in series. People say this is confidential, which means the guy who is trying to access the Jack Reacher's file doesn't have the access to that information, because that information is confidential. Right now, still, Reacher's information get compromised in season one. Right, that guy got that information, so things can happen. Right, so how can we achieve this confidentiality? We can achieve it through encryption and, of course, access control. Like we were talking about, in different layers they should have access control. If it get compromised, the data should be encrypted. Data classification and rights management, so that if it is tagged as classified, then the proper security and other policies would be applicable. Right, so that is confidentiality. So what are we trying to achieve with all the security? We trying to achieve the confidentiality, and we are trying to achieve the integrity. And before we talk about the integrity, there are a few things I would like to add on the confidentiality. For example, a bank encrypts all customers' transaction, ensuring hackers can't intercept them. That is confidentiality, one of the aspect of it. Or a hospital restrict access to the patient's records, so only doctors can view them. That is again confidentiality. Now, if the doctor viewing that patient's records, it should be as it's supposed to be, means integrity. Right, nobody should. For example, you have seen even that scene in many movies or series. The Somebody modify the record, like there is no issue with the kidney or heart, and they make it look like as per the report, and doctor inject something, and the mission accomplished. The point is, integrity is, it should be as it's supposed to be. Right, confidential is only that doctor can see the patient's record. Integrity is the record is absolutely uh, unmodified, or it's as it's supposed to be, pure. Right. Pure is the right word, not sure, but you got the point, right? So that is confidentiality. Will explore the integrity, but prior to that, how it is related to defense in depth. The very first thing, when we talk about confidentiality, we talk about identity and access control, which is the second layer in defense in depth: identity. Right, when we talk about confidentiality, we talk about encryption, because confidentiality on whom? On data. Then there is a data layer. Right. So these all are related to each other. These are the principles on which the security approach is applied. Indirectly, by all these security approach, we are trying to make our data confidential, integrity, and the availability of data. Right. So with the example of this doctor patient, you know what is integrity? It's ensuring data remains correct and unmodified. Right. And how can we achieve the integrity? We should have some kind of check, like a hashing, like a digital signature, or checksums, or database integrity constraints, version control, logging. Those kind of things will help us. And to achieve the integrity, what are we doing? We are preventing unauthorized modification. Again, identity, as you see from the defense. right? We are using encryption or hashing mechanism, checksums and all. So we are protecting data, right? And of course, we are protecting against the data tampering in transit when data is in move. So network security comes into the picture. That's how we are achieving the integrity. Then the availability. What exactly all we are, everything, what, why we are doing it, we are doing this everything, whatever we are doing till now, all the security and defense through these principle we are doing because this guy somewhere who is trying to access his application can access this application whenever he wants, or like in the night, in the day, whether it's Instagram, Facebook, or Amazon. If you want to access, you want to buy something, you open the Amazon and you order. Maybe it's day, night, noon, does not matter. This is what the availability is, right? It means ensuring services, application, and data are available when accessed. Available to whom? To the authorized person. So all users, all consumers, all customers are the authorized folks to buy it from that perspective, right? So it should be available. Now, to make system available, all these layers should be protected. Only then the system will be available. Of course, there is a resiliency practices altogether, but from this perspective, if somebody will compromise the physical layer, if this guy try to access, there is nothing, right? Any layer compromised, ultimately they are making your application getting down. Or if data layer is encrypted, ransomware, you can, if you access, you can't get anything. So availability is getting compromised. So how can we make sure availability is good? First of all, everything is secured. Then we could plan from the resiliency perspective, like HA or redundancy, DR, backups, load balancing, auto scaling. These all are from the resiliency perspective. But resiliency will only work when you have everything secure. Otherwise, if something compromised, if anything compromised badly, your resiliency will also get compromised because of lateral movement, right? Or so these are the basic three principle on which the security works. But as I was saying, the two more added recently, I guess, maybe uh, I get to know recently. Like last year or last to last year, I was reading something and I get to know about these things. Anyways, authentication, we all know, ensuring users and systems are who they claim to be before getting access. How it is achieved? Through all the mechanism we talked about on the identity, like MFA, biometrics, single sign-on, conditional access, and all those kind of things by which we can check the authentication. We can verify the identities before granting access. Right. So that is authentication, and non-repudiation is preventing users from denying they performed an action. For example, some intelligent guy tried to shut down the virtual machine and say I didn't, but there is a log which can say you did, right? So this is more like ensuring actions cannot be denied, right? For example, you have dropped the email to the your peer or customer or somebody, like this is what the information is, but the other guy is denying I have never received that information. You can show in the sent items, the basic simple example, right? Now this is non-repudiation. These are also the part of CIA now, so that when you think from security perspective, you also think a proper logging, the mechanism the other guy cannot deny, right? All right, so with this, we have completed this topic, describe defense in depth, and talk about CIA triad. I hope it was informative and you guys enjoyed it. Well, thank you for watching, and you guys have a wonderful day. Take care.